Gravitation. We now find the gravitational force between two masses. Every body attracts other body with a force because of their mass. This force of attraction is known as Newton's force of gravitation. So this force actually depends on the mass of these bodies and the distance between them. So according to Newton, the force of gravitation is proportional to product of mass. Suppose this is m1, this is m2. If r is constant, then the force of gravitation is proportional to this is r is constant. Then the gravitational force is proportional to product of masses, and if m1 m2 constant, then force of attraction is inversely proportional to the square of distance. This is when m1 m2 constant. This is also called inverse square law. So if we combine both, then we get F is proportional to m1 m2 by r square. So to replace this proportionality constant, we will introduce equal sign and a constant m1 m2 by r square. This constant is called universal gravitational constant. So the dimension of G can be found, G equal to F r square by m1 m2. So F has the dimension m l t minus 2, r square is l square, this is m, again m. Now this m cancel out, so this is m minus 1 l cube t minus 2. So value of G in SI system is 6.667 into 10 to the power minus 11. This is per kg, then meter cube per second square. This G is constant and it is universal constant. Now we want to find how to find out the strength of the gravitational field. Suppose this is the mass. Now surrounding this mass, if any other mass be kept, then it can attract this mass. Now we will measure how to find out this strength of this gravitational field. Now this strength can be found out either by gravitational intensity or by gravitational potential. This is, we now find the expression for gravitational field. How to measure this gravitational field? Now gravitational field means when one body exerts force on another from a distance without any actual contact, this force is known as field force. Now the region surrounding the mass, this region surrounding the mass, where if another mass is kept, suppose here we keep another mass, and if it experiences a force, then we say that the region is in the gravitational field of the given mass. Now gravitational field, the strength of the gravitational field can be measured either in terms of intensity, this is force per unit mass, or in terms of potential. Now we will see what is gravitational intensity and what is gravitational potential. So gravitational intensity is defined as the force experienced by a unit mass kept at that point. So suppose here if you keep a unit mass, this is the mass m, at a distance r we keep a unit mass. So what will be the force? Force equal to G, this is the given mass, this is the unit mass by square of distance, So this gm by r square, this is the force experienced by the unit mass. This is called intensity at this point. So intensity is nothing but the force per unit mass. So unit of intensity is, intensity will have the unit of force per unit mass. So this is Newton per kg. Now what is gravitational potential? Suppose when we want to bring a mass from infinity up to this point, that is infinity means beyond the gravitational field up to this point. So whenever this mass is here, then the work done is stored in this mass. This work done is called the gravitational potential at that point. So work, this is stored, whatever work you will do to bring a mass in the gravitational field at a point, this work will be stored in the form of potential energy. So this is potential energy. So potential energy per unit mass is called gravitational potential. So suppose we have a gravitational field of this given mass. Okay, now we want to bring a unit mass from infinity up to this point. So whatever work we will do, it will be stored here. This work is stored in the form of gravitational potential energy. Now instead of any mass m dash, if we bring a unit mass, then this work done stored in this body as a potential energy is called the gravitational potential. So how gravitational potential is related to gravitational potential energy? Potential means gravitational potential energy per unit mass. So if the work done is more, then we say that the strength is high. Similarly, if the intensity, that is the force experienced by unit mass, is more, then we say that the force field, the gravitational force field is of higher magnitude. So by either by intensity or by work done, that is by either by force per unit mass or by work done per unit mass, we can find out the strength of the gravitational field.